Hello, hello, hello. Mr. Kazmarowski here. Going to go over page 229 and 230 in your packet, the 6.5 worksheet. So watch this worksheet. This is the last assignment before spring break. Watch this video. It's the last assignment before spring break. In class, we talked about side, 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 and side angle, side similarities. So we're going to apply that to some of these triangles here. All right, going to this first question is given LMN or RST, circle the one that is similar to the first triangle, triangle ABC. So what they want us to look at here is they want us to compare the measurements to of the one triangle to the other triangle. So because they're giving us all sides. So this is a side, side, side set of problems right here in numbers 1 and 2. So first they want us to compare triangle 1 to triangle 2. I'll call that 1 and 2, and I'll call this one 3. So if we're comparing 1 to 2, we'd set up 3 ratios. And when I look at ratios, I should shortest side over shortest side, middle side over middle side, longest side over longest side. So if I look at triangles 1 and 2, my short side in 1 is 10. My short side in triangle 2 is 6. I have another 10, but I don't have another 6 in the second triangle. So I'd have to put that over an 8. And then my longest side is 12, and I'll have to put that over one of the 8s. So if you look at all 3 of these ratios, they do not simplify to the same thing. 10 over 6, that divides by 2, that'd be 5 over 3. 10 over 8, that divides by 2, that'd be 5 over 4. 12 over 8, that divides by 4, and it'd be 3 over 2. So none of those ratios. So it's not LMN. That's one not similar to ABC. Now we should check the ratios between 1 and 3. And the ratios, so shortest over shortest would be a 10 over 5. And then another 10 over 5. And then a 12 over 6. Aha, those are all 2 over 1, 2 over 1, 2 over 1. Because we can divide 10 and 5 by 5. We can divide 12 and 6 by 6. And it is triangle 1 to triangle 3. Those are similar. Those are similar. All right, same type of work in number 2. Let's do 1, 2, 3. Notice sometimes, this one I think is kind of obvious because 3 definitely doesn't look similar to number 1. So we're going to compare 1 to 2. So shortest is 8. I'm going to put that over 4. Second longest is 9. And I'm just going left to right here. I'm taking my measurement from the left triangle first. 9 and then 4.5. And then 10 and 5. The longest in the first triangle is 10. The longest in the second triangle is the 5. And those all simplify to 2 over 1. You're not always going to get 2 over 1. Sorry, that's a 1 there. But it would be these two that are similar. This one and this one. And just to show you that 1 to 3 is not similar, so you'd go 8 over 6, shortest over shortest. Middle is 9 over 9. That's the middle side in triangle SRT. And then 10 over 12. And if you simplify those, this first pair divides by 2. That'd be 4/3. The second pair divides by 9, 1 over 1. And then the third pair divides by 2, and it'd be 5 over 6. So yeah, there's not similarity. You got to have the same ratio to have side, side, side similarity. Okay, so that's 1 and 2. Done. All right, question number 3. Number 3 looks like it's going to involve angle, side angle, because they give us one angle. They give us this 85 and this 85. So it looks like they're trying to do ASA similarity. So check it. It says, first says determine. So the angles, sorry, I wrote that wrong. It's not angle, side angle. It's side angle, side similarity. We only have one angle, SAS similarity. All right, sorry for that A and S mistake there. So the 85s match. Now we have to check the ratios of the sides. So I'm going to use the small triangle first, and I'm going to pull its smallest side, 3, and then I'm going to pull the smallest side of the second triangle, that'd be 12, and then I'm going to pull 4, the second biggest side that they give us in the small triangle, LJK, and I'm going to compare that to the 16, the biggest side they give us in the other triangle. And if I simplify both of those, 3 over 12, that simplifies to 1/4, 4 over 16. That simplifies to 1/4. I can divide that first pair of ratios, or the first pair of numbers, by 3. The second ratio, I can divide them both by 4. So yeah, these are equal. So we do have side angle side similarity. So we put a big yes there. They're similar. If they are similar, write a similarity statement and find the scale factor. Well, this is the scale factor. Now, the similarity statement, you can start with any order you want to. I'm just going to go triangle JLK. So now here's the deal. I went JLK, so I went across the short side to the 85. So I have to go across the short side to the 85. So I'm going to have to go YXZ. Is similar to triangle YXZ. Now, if you did this problem on your own, check your order of your two triangles, because there's other answers for this that are still correct. Because like here's, I'll just give you one other answer. If you went triangle LKJ, that starts at the 85 and goes across the long side, then it would be XZY. And that would be a good similarity statement. So both of those are right. You don't have to do them both. But all right, now number 4 and 5, those are going to be SAS checks again. All right, they're going to both be SAS checks. We're not going to have to check 3 ratios like we did in 1 and 2 up above. We're going to have to check 2 ratios. The reason why we don't have to check all 3 ratios is because in this one, the 2 triangles have angle P, and in this one, the vertical angles make the angles congruent. What I do have to do, though, for number 4 is put a star by it. It's kind of a crazy one. I'm going to pop triangle PTQ out of here, and I'm going to rotate it to the left. All right, or actually kind of reflect it to the left. So when I pull out PTQ, I'm going to redraw it over here. All right, like that. P is still going to be at the top. T is going to get flipped over to the left side, and Q is going to be right there. I'm going to transfer its lengths over. So PT is 4, PQ is 6, and TQ is 5. So 4, 6, 5. Now, I think it's almost worth a redraw of the big one. All right, the big one is PRS. All right, the big one's PRS. Now, on PRS, we have 10 down here. If we added up the 6 and the 2, it would be 8 on the PR side. And if we added up the 4 and the 8, it would be 12 on the PS side. Oh, actually, you know what? This one is, we could do SSS or SAS, because they do both have angle P. So we do have one angle. But we could do SSS and check all 3 ratios. But check it out. If I go shortest side in the small one over shortest side in the big one, second side in the small one over second side in the big one, and longest side in the small one over longest side in the big one, do those all look like the same fraction? 1/2, 1/2, 1/2. Yeah. So we're good to go here. So this could be either SSS or SAS. It could be one or the other, okay? It does tell us to write a similarity statement, so I think the redraw really helps with our similarity statement. And the similarity statement, I'm going to go with the small one first, triangle PTQ. And that's easy to follow in the redraw. It starts at P, goes to T, and then to Q. I'm going to have to go PRS, triangle PRS. All right, so that would be a good similarity statement. There are other ones that are also correct. Now, this one, they only give us 2 sides. They don't give us this side and this side, so we're definitely not doing SSS on this one. But let's see. I'm going to go shortest side is 7 and shortest side is 3.5. Second side is 8, second side is 4. Oh, these are just going to simplify to 2 over 1. 2 over 1. Yeah, so the bigger triangle is twice as big as the smaller one. And so we're good to go. SAS is the reason. Notice I only checked 2 ratios because I don't have a third ratio to check there. And, oh gosh, a similarity statement. If I go GHK, all right, that's the big triangle, is similar to, now G to H goes across the blank side, and then it goes across the short side 7, GHK, if you follow that around. So I have to go NMK, So I go across the blank side, NM, and then across the short side, 3.5, okay? So that's a little bit tricky right there. All right, keep on keeping on. All right, flipping to page 230 right now. Flipping to page 230, it's almost Easter break. Or you might be watching this during Easter break, or you might be watching it after Easter break. I'm actually recording this on March 20, what is today? 24th, okay. All right, here we go. Number 6 and 7. So no pictures, but they give us information. They give us all the sides in number 6, so they're telling us to work with SSS. They give us 2 sides and the included angle. So they're giving us SAS here. Let's see. So we just have to check the ratios in number 6, and we just have to check ratios in number 7 because they already tell us that these angles are congruent. So that's the A part of SAS. So I'm going to go smallest over smallest. So I started to look at this one. I was like, oh, it's another 1/2 one because I was thinking smallest is 8 and smallest is 16. Second biggest is 10. Second biggest is 20. Biggest is 14. And then biggest in the lower triangle is 26. And this one's going to fall apart because 8 over 16 simplifies to 1/2, 10 over 20 simplifies to 1/2, and 14 over 26 does not simplify to 1/2. It simplifies, you can divide it by 2, and it's like 7 over 13. So the answer to number 6 is that they are not similar. All right, since the ratios don't play out to be all the same. All right, not similar. All right, but it's always smallest over smallest, middle over middle, biggest over biggest, and that's all we have to do there. It does say to sketch the triangles using the given description. They don't really give you enough room to sketch them, so you don't have to sketch them. All right, but just test the ratios. Write down your ratio test. Now, if you don't like simplifying fractions, you can do these all into decimals and check if the decimals match. 8 over 16, if you type that in as a division problem, which you would on a calculator, would be 0.5. 10 over 20 would be 0.5. And 14 over 26, I don't know that off the top of my head, so I'm typing it into a calculator as we speak, 0.538. So, the decimals don't match. So decimals can be used, and 0.5, 0.5, 0.538 don't match, so that's just another guarantee that they're not similar. All right, so we only have to check 2 ratios in this one because they only give us 2 side lengths in each triangle. So shorts, I'm going to use the top one first. The shortest is the 15. That compares to the 5. Always go over the corresponding side. And you know it's corresponding to because AB is the first 2 letters, DE is the first 2 letters. BC is 24. That's the biggest side they give us in the upper triangle. And then that has to compare to 8. And that's BC, notice that's the second and third letter. EF, that's the second and third letter. They're corresponding. Oh, these simplify to 3 over 1. And we're good to go because we have 2 equal ratios and we have that equal angle, okay? So we're good to go here. This is yes, they are similar. By SAS. All right, number 8 through 11. What do we got going on here? We got this 4-sided figure. We got some parallels here. The parallels are going to help us because we're going to be able to put some markies in some congruent angles. So it's talking about triangle ABC, which is up here at the top. I like the parallels because it's going to give us alternate interior angles here and here, okay? We have vertical angles, so we have this. We do a double arc there. All right, so it wants us to compare that upper triangle ABC, which I'm going to trace right now in red. And with where I just placed angle marks, we've got it, all right? Because remember, there's a third way that we can prove 2 triangles similar. It's angle-angle similarity. So this one we're going to use angle-angle with. So that is going to give us, let's see, if it goes ABC, the unmarked angle to the single arc, then we're going to have to go EDC, unmarked to single mark, triangle EDC right here. And then number 9, it wants us to find the measure of angle DCE. Well, that's the double arc in the middle. Well, that's a linear pair with the 135. So I'm going to use this straight line right here and just do 180 minus 135. So DCE would be 45 degrees. So that means both of those angles in the middle by C, above and below, are both 45-degree angles. The length of AB, now here I'm going to have to use a proportion, all right? AB compares to the 12. So I'm going to put an X up there on AB. So I'm going to say 14 is to 16. So I like the 14 and the 16 because notice they're in between the single arc and the double arc. So 14 is to 16. They're corresponding sides in the small triangle and the big one. The one at the bottom is a little bit bigger, all right, as X is to 12. That's what I have to cross multiply and solve. You're going to get 16x equals 168. 16x equals 168. And when you do the division, you are going to get a 0.5. 168 divided by 16 is 10.5. Some people think it should just be 10 because they look at the 16 and the 14 and they say, hey, just minus 2. But you can't just add and subtract when you're doing proportions. You gotta cross multiply and divide. So 10.5, that's the distance across the top here. If I wanted to pencil it in, I could pencil it in up there, 10.5. Up there by AB, across that top length. Then, I don't know what 11, what are they asking for? A couple angles added together. Angle CAB, which is the unmarked angle at the top triangle, and angle ABC, which is the single arc angle. This one's kind of a stretch, but it's just 135. Since the double arc is already 45, the other two angles have to add up to 180. So it's just 180 minus 45. It's 135 degrees. Don't stress out about that one. All right, that was just kind of a throwback question a little bit. But they were asking for the sum of these two angles here and here, and they would add up to 135. Because you could, yeah. All right, last problem, pine tree. Can you smell the pine tree? Does it smell like Christmas? All right, so we're using this mirror to get like distance away from mirror is to our height as distance away from mirror is to the tree's height. So we'll just use the corresponding pieces. The reason this works is because notice these congruent angles right here, okay? And we're also assuming that the person and the tree are at 90-degree angles, so they're similar by angle-angle similarity, okay? What is the height of the pine tree? So we're going to say 6 is to H. Your height is to the pine tree's height, as your shadow is to the pine, or not shadow, distance away from mirror. I always think these are shadow problems, but this is a distance away from mirror problem. So 3 times H, 6 times 11, and divide by 3. The height of the pine tree is 22 feet. All right? Can you fit that type of pine tree in your house for Christmas? No, I don't think so. A 22-foot pine tree. That would bust up through the ceiling, that's for sure. Most houses have like 8 to 10-foot ceilings. All right. Number 13 says, a different kid tries the same process, and they are only 5.5 feet tall, and they have to look at the mirror, and the mirror's still 3 feet from them. All right. How far from the base of the tree? Okay, so the tree isn't going to change. The tree is still 22. But they're trying to figure out, well, how far will it end up being from the base? So we're missing that distance. So 5.5 is to 22. Your height is to the tree's height, as your distance from the mirror is to the tree's distance from the mirror. So they just made this one up and said, let's change the height of the kid, and let's figure out how far from the tree we have to be. So still going to get 5.5x and 66 when we cross multiply. But now when we do the divide, 66 divided by 5.5, you end up getting x is equal to 12. So you would have to put the mirror a little bit further away from the tree. All right, that's cool. All right, similarity. Look at all the proportions we set up. All right, we'll talk to you guys after Easter break. And everybody take care. And April 6th, everybody will be back at school. All right, Mr. Kazmarowski out.